Hello and welcome to my channel. In this video, I'm going to take you through the topic electronics. By the end of the lesson, you should be able to differentiate between insulators, conductors, and the semiconductors. Electronics is a topic which is concerned with electrical circuits. Electrical circuits can be used to control machines, processes, store and transmit information. Devices in our homes such as TVs, radios, computers, and calculators are some of the recent developments in the field of electronics. These electronic devices have various electronic components that perform different functions. Some of the components that we have learned so far are resistors, diodes, transistors, and capacitors. One major component we are going to discuss in this topic is the semiconductor diode. The functioning of the semiconductor diode is based on the behavior of certain materials called semiconductors. Hence, the reason why we need to differentiate between conductors, insulators, and the semiconductors. So that basically means that in this topic, we'll majorly discuss the semiconductors. To help us understand more about these semiconductors, we need to discuss the energy band theory. According to the energy band theory, electrons exist in energy levels in an atom. In solids, where many atoms are close together, the energy levels split in smaller energy levels called bands. The outermost unfilled energy level, which contains the valence electrons, splits more easily into bands than the inner levels. The main bands are the conduction band and the valence bands. These bands have a gap between them. The conduction band consists of free electrons that are responsible for conduction, while the valence band comprises of valence electrons, which move to the conduction band when provided with sufficient energy. The gap between the conduction and the valence bands is called the forbidden gap. The forbidden gap is used to distinguish between insulators, conductors, and semiconductors. Now, let us look at the differences between insulators, conductors, and semiconductors based on the energy band theory. Insulators. Insulators do not conduct electrical current. There is a large gap between the empty conduction band and the completely filled valence band. This makes it difficult for an electron to cross the forbidden gap to the conduction band. So in simple terms, the conduction band does not have electrons, and the electrons present in the valence band are not able to reach the conduction band because of the large gap between them. Thus, we can say the absence of electrons in the conduction band makes a material an insulator. Conductors. In conductors, the valence and the conduction bands overlap. This means electrons can move freely from the valence band to the conduction band. Thus, there are many electrons in the conduction band available for conduction. The availability of electrons in the conduction band makes that material a conductor. Lastly, let us look at semiconductors. In semiconductors, electrical conductivity lies between those of good conductors and the insulators. In semiconductors, the forbidden gap is small compared to that of insulators. Remember, we already said that the conduction band has no electrons, while the valence band has electrons. When the temperature of a semiconductor is increased, an electron in the valence band can gain enough energy to enable it jump to the conduction band. This means that the conductivity of a semiconductor increases with increase in temperature and reduces with decrease in temperature. When an electron jumps from the valence band to the conduction band, it leaves behind an empty space. This space where an electron should be, but it's not because it has jumped to the conduction band, is called a hole. A hole is defined as an absence of an electron, and it's regarded as positive. An electron within the valence band will be attracted to the hole. As the attracted electron jumps into the hole, it creates yet another hole which is filled by an electron, and the process continues. In the end, a hole is therefore seen moving in the valence band while electrons flow in the conduction band. The movement of holes in the valence band and the flow of electrons in the conduction band is responsible for conductivity in semiconductors. As the temperature is increased, the number of free electrons and holes increases. Thus, in semiconductors, conductivity increases with increase in temperature and decreases with decrease in temperature. That is the end of our lesson. In summary, we've been able to differentiate between insulators, conductors, and the semiconductors in terms of their forbidden gap. We saw that in insulators, the forbidden gap is large, making it difficult for an electron to cross over to the conduction band. In conductors, we saw that there's no forbidden gap since the valence band and the conduction band overlap, thus making it easy for electrons to move freely between the conduction and the valence band. In semiconductors, we said the forbidden gap is small, such that if an electron was to gain enough energy, it can be able to cross over to the conduction band. Thank you for watching. See you again next time, where we discuss types of semiconductors.